Properties of inequality. First property, that will be trichotomy property. For any numbers a and b, only one of the following is true, and that is known as trichotomy property. Trichotomy property. Next is transitive property of inequality. For any real numbers a, b, and c, one of the following is true. If a greater than b and b greater than c, then a greater than c. Same as a greater than less than b, then and b less than c, then a less than c. Addition property of inequality. The same number must be added to both sides to retain the inequality. One of the following is true. If a less than b, then a plus b less than b plus c. So this is a less than b. So positive or plus c is added to the left side, then it is also added to the right side to make it balanced. If a greater than b, so a greater than b, so we add plus c to the left side, then it is also found in the right side. If a less than b, then a greater than less than b, then it was added negative c to the left side, then you also add negative c to the right side. Or simply a minus c less than b minus c. Example 1. 3 greater than 1. So 3 greater than 1. Any number that is added to the left side, you will also add to the right side. When we add positive or plus 2 here, you will also add plus 2 to the other side to make it balanced. That's why 5 greater than 3, that's why that makes it true. Example 2. 5 greater than less than 9. So 5 less than 9. So if we add negative 2 to this side, we will also add negative 2 to the other side to make it balanced. So it is written as 5 minus 2 less than 9 minus 2. 5 minus 2 is 3. 9 minus 2 is 7. That's why 3 less than 7, then it is true. So correct. Multiplication property of inequality. Case number 1. When each side of an equality is multiplied or divided by the same positive number, the inequality symbol remains the same. As you can see here, if a greater than b, then a times c greater than b times c. For this one, a less than b, then a over c less than b over c. You divide both sides by c, and here and also here you multiply c to this side, then you also multiply c to this side. Example, 5 greater than 2. 5 greater than 2. You multiply 3 to this side, to the left side. You will also multiply 3 to the right side to make it balanced. 5 times 3, that is 15. 2 times 3 is 6. So 15 greater than 6, and that is true. Example number 2. 12 less than 18. So 12 less than 18 I mean. We multiply 1/3 to the left side. We will also multiply 1/3 to the right side. Any number you multiply to that side, you will also multiply the same number to the other side. 12 times 1/3, that is 12 over 3. 8 times 1/3, that is 18 over 3. 12 over 3, and that is 4. 18 over 3, and that is 6. 4 less than 6, and that is true. That is multiplication property of inequality. Case number 2. When each side of an inequality is multiplied or divided by the same negative number, the inequality symbol must be reversed. Again, it must be reversed. Please take note of that one. If A greater than B, then A multiplied by negative C. You multiply negative C here. Then you will also multiply negative C to the left side. So A times negative C, that's why negative AC less than negative BC. It is still the same. For this one, if A less than B, then A times negative 1 over C, then greater than B times negative 1 over C, or it is negative A over C greater than negative B over C. It is still the same. Example 1. 5 greater than 2. So 5 times 3 greater than 2 times negative 3. So 5 times 3 is negative 15. 2 times negative 3, it is negative 6. It is false. Right. To make the statement true, 15 less than negative 6. That's the correct answer. Example 2. 12 less than 18. We multiply 12 by 1/3 to the left side. Then we will also multiply negative 1/3 to the right side. So negative 1/3 times 12, that is negative 12 over 3. Negative 1/3 times 18, that is negative 18 over 3. Negative 12 over 3, that is 4. Negative 18 over 3, that is negative 6. So negative 4 less than negative 6, and that is false because negative 4 is greater than 6. To make the statement true, negative 4 greater than negative 6. Differentiating equations and inequality. What's the difference between equation and inequality? An equation is a statement that shows two numbers or two expressions are equal, while inequality is a statement that shows two numbers or two expressions are not equal. Examples for equation: 2 plus 7 is equal to 9. It is equal because when you add 2 plus 7, that is equal to 9. X plus 5 is equal to 12. It is an equation. 2x minus 3 is equal to 7. 4x plus 12 plus 6 is equal to negative 6. That's an example for an equation. While for inequality, x greater than 5, x less than or equal to 10, y less than 15, y greater than or equal to 20. As you can see, there are differences. An equation, I will give you the clue. If that problem is an equation or inequality, when we say equation, there is an equal sign. While inequality, the symbol is greater than, less than or equal to, less than, and greater than or equal to. That's the clue. An equation is only, the clue for equation is there is only an equal sign to make it an equation. Solving linear inequalities in one variable. Solving linear inequalities in one variable. In solving inequalities is like solving equations. They are just the same, but they have differences in terms of symbols. You just have to consider the inequality symbols and the factors that may affect the inequality. Using addition property of inequality, example 1, x plus 7 greater than 3. So x plus 7 greater than 3. In addition property, when you, from the time you isolate x, you need to multiply that by -7 so that x will remain. So when you, subtract -7. When you subtract -7 to the left side, you will also subtract -7 to the other side, or to the right side. So x plus 7 minus 7, that is x plus 0. 3 minus 7, that is -4. So x plus 0 is x greater than -4. So we need to graph x greater than -4. So greater than -4, the graph is going to the right because it is greater than. Then our circle is an open circle because it is only greater than. The interval notation is -4. They're all open and closed parentheses. -4 and infinity. Set builder notation is braces x of x greater than -4. To check if x is equal to -1, for checking, choose a number belongs to. So we need to choose any number for x. So -1 plus 7 greater than 3. So 6 greater than 3, and that is true. Using multiplication property of inequality, example 1, 4y less than or equal to -12. We need to isolate y by applying the multiplication property of inequality. So 4y will be divided by 4, or 4y times 1 over 4. Less than or equal to -12 over 4, or -12 times 1 over 4. 4y over 4, and that is equal to y. -12 over 4, and that is equal to -3. So y less than or equal to -3. Then we need to graph. The graph is going to the left because it is less than. Then our circle is a shaded circle because it is less than or equal to. Interval notation. Quantity negative infinity. Infinity is always a parenthesis. Please take note of that. Comma, -3, then a bracket. Set builder notation is y of y less than or equal to -3. Now, let's go on to using more than one operations. Example 1, 4 minus 2x less than 8. Step 1, we need to isolate 2x. This one, we need to isolate -2x. So we add -4 to the left side so that 4 will be cancelled out. And also, from the time you add -4 to the left side, you will add also -4 to the right side to make it balance. Then 4 minus 4, and that is 0. Cancel out. Remaining will be -2x. 8 minus 4, and that is 4. So that will be -2x less than 4. Then we need to isolate x by applying the multiplication property of inequality. So we divide both sides by negative 2 to this side, then negative 2 to this side to make it balance. Negative 2x over negative 2, that is positive x. 4 divided by negative 2, that is negative 2. So the result is x greater than negative 2. Then we graph. X greater than negative 2, then it is going to the right. Then it is an open circle because it is greater than. Interval notation. Open and close parentheses, negative 2, positive infinity. Set builder notation, x of x is greater than negative 2. Since the factor or the divisor is negative, change the inequality symbol to its opposite. That will be the multiplication property of inequality, case number 2. That's why the symbol here from less than turn to greater than. Please take note of that.